Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So right now we are going to see our topic 3 on stress and deformation in cylinder. If in the reference book, it's actually from the chapter 10 page 244 until 261. Okay, for the chapter briefing, this chapter investigate the stress and deformation that occur in internally or externally pressurized cylinder. It means in this chapter we are interested to know the stress and deformation that occur whether from the internal or external pressure cylinder, whether it comes from the internal pressure or external pressure of pressurized cylinder. So actually this one is a common beverage can along with the food containers. These are the most common pressure vessels. So these are the common simple pressure vessel. So this basic geometry sees many practical applications including pressure vessel such as gas storage cylinder, food and beverage can and bottles, fuel tank, hydraulic actuator and gun barrels, press and shrink feed, hydraulic and pneumatic tubing used for delivery of pressurized fluid, and pump and motor. So in this chapter we have several subchapters. For example, we have 10.2, 10.3 until 10.6. So for 10.2, the subchapter is on the tolerance, allowance and fits. It's actually is to understand the demanding design specification required for press and shrink fitting. It means this subchapter will explain us to understand what is actually the design required when we are designing for the press and shrink fitting. So after that, they summarize the class of fit and also what is the recommended tolerance for different application. After that, 10.3 pressurized effects is on the membrane stress 14 wallet pressure vessel shown, and then full linear elastic solution for thick wallet pressure vessel is derived and simplified for common special case. So actually it's on the thin wallet pressure vessel, and then another one is for thick wall pressure vessel. So all this theory is then we apply on application of press feed and shrink feeds. So it is determined how much assembly force is required to press feed and how much torque is permitted for both press and shrink feed. So for the introduction, again, this chapter deals with the internally and or externally pressurized cylinder. Remember, it's interested on the internal or external pressurized cylinder. Many important engineering applications rely on this condition. The material in this chapter is important for understand machine element presented later in the text. So actually, this topic is important because it will the fundamental in this chapter will make you to understand or require you to understand in the next chapter. For example, the material developed in this chapter is important too for shafting in chapter 11, or machine element in chapter 13 for rolling element bearing, chapter 12 for hydrodynamic bearing. So again, the section we have, again we highlight here 10.2 for tolerance and fit. It's actually a concept that essential for design of mating part. 10.3 pressurized effects. It introduces you about thin and thick wall cylinder, and then the stress that develop due to the internal and external pressurization. After that, 10.4 is about rotational effect. 10.5 press feed, while 10.6 shrink feed. It using the theoretical approach developed, press and shrink feed are covered in section 10.5 and 10.6. So now 10.2, we start with the subchapter 10.2 about tolerance and fits. A number of definitions about tolerance are important in design. Here, about the tolerance, there are four important definitions. One is tolerance, TL, nominal diameter, represented by D, allowance, represented by A, and interference, So actually, the tolerance, TL, is actually the maximum variation in the size of a part. Two type of tolerance are, so actually it's a maximum size of a certain part. So there are two type of tolerance. One, we have bilateral tolerance. Another one is unilateral tolerance. When we say bi, it means two. When we say uni, it means one. Okay, it means bilateral is a part is permitted or to vary both above and below. It means two. It can vary whether it's above and below the nominal size. For example, 25 plus minus 0.030. While for the unilateral, a part is permitted to vary either. It means only one, whether it's above or below the nominal size, but it cannot be both. For example, 25 plus minus 0 plus 0.000 or minus 0.030. Okay, that one is about tolerance. While for the nominal diameter T is actually the approximate size. So allowance and tolerance are applied with respect to the nominal dimension. So actually for the nominal dimension, it will include allowance and tolerance. Okay. For the allowance, the actually is a difference between the nominal diameter of matching parts. It's actually difference. The difference allowance is used when the matching part have measurable positive gap between them. So if they have gap between the male mating part with the female, the positive gap, so that one we call allowance. While the inverse of the allowance is we call interference. The actual difference in the size mating part, interference is used when the mating part have overlap and can be considered inverse of the allowance. It means sometimes the male mating part for the female, the male is bigger than the female. So that time we call interference. While the allowance, the size of the male mating part, for example shaft, is smaller than the female mating part, for example holes. So remember that tolerance of the shaft TLS, we add S over here, and the hub tolerance for the hub TLH may be different. Okay, right now, so we realize that it is impossible or not practical to form a manufacturing perspective to make a part that n exactly size. So because of this impossible and practical, so we are use tolerance to control the variation between the mating part. So right now we are going to find how we are going to design, for example, for a certain shaft and hub, what is the tolerance or allowance or interference. So the first thing we need to do is we start with the step 1. Step 1 we refer to table 10.1 over here. So table 10.1 describe 8 class of fit. So we have class here, we have class 1, 2, 3, 4, 5, 6, 7 and 8. We have loose, free, medium, snug, wriggling, tight, medium and shrink. The type of fit here, we have clearance, 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 and then interference, 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 and interference. So we see the type only two, clearance or interference, and their application. So application is depend on the class. Note that the class 1 until 4, the member are interchangeable. So 1, 2, 3, and 4 interchangeable. But for class 5 to 8, the member are not interchangeable. 5 until 8 is not interchangeable. So when we have no the part we are going to produce, whether in the class 1 until 8. So, and then when we, okay, here, when we know the class of it, the next thing we need to do is to find the tolerance that's suitable, depends on each class. Okay, this is on the step 2. So step 2, we are referring to table 10.2, recommended tolerance in millimeter for class of fits. Okay, table 10.2 give the tolerance for various class of fit in millimeter. So this one table is in millimeter. Remember, there are also table in inch, but this time we go using the ISI unit. So we take table that using the millimeter. In this table, the nominal diameter is designated by D. So here D here is the nominal diameter. Also here and here and here. When we already determine the allowance, interference and tolerance from the equation over here, the next step we need to find the maximum and minimum diameter of the hub. So the next step is the step 3 using the table 10.3. So table 10.3 give this dimension for two types of fit, the clearance and interference. We have clearance and interference. So the table 10.3, you are going to determine the maximum and minimum diameter of shaft and hub. So we have shaft and hub diameter for two types of fit. So table 10.2 and 10.3 does establish the upper and lower limit of the shaft and the hub diameter for the 8 class of the fit. Okay, to strengthen our understanding, let we start with example 10.1, interference and the class of fit. So the given question is, a medium force interference fit is applied to a shaft with a nominal diameter of 75 mm. So this one is D. So the type, okay, determine the interference, the hole and the shaft tolerance, and the hub and shaft diameter. So how we are going to solve it? The first step, remember, we start with the first step from the table 10, class of fit of 7. How we know? Depends on this one. They mentioned that this is a medium and force interference. So it's medium and interference. So it's actually the class 7. So when we know the class 7, we proceed to the step 2, where we are using the table 10.2. So focus on the class 7. So class 7 over here. So here is the for class 7. We have the, if you want to determine allowance, so there is no formula for this class. For the interference, we're using this formula 0.005D, where D is the nominal diameter. Hub tolerance TLH is equivalent to 0.052D on the power of 1/3, and the shaft tolerance TLS 0.052D power of 1/3. So we determine it. So we have interference over here, the formula. So we plug in the value. So D is actually the nominal diameter over here. So we insert here and we get the interference equivalent to 0.0375 millimeter. While for the hub tolerance is same as the shaft tolerance. So the equation is 0.0052D to the power of 1/3. So we put into the formula, so we get equivalent to 0.0219 millimeter. So step 3, from the table 3, for the interference, we are going to determine the maximum and minimum diameter of shaft and hub for two types of fit. Since it's in the group of interference, so this is the equation. So for the maximum hub diameter DH max, using this equation D plus tolerance of hub. So we put the value. So we get 75.0219 millimeter. While for the minimum hub diameter, equivalent to D, nominal diameter, so equivalent to 75 millimeter. While for the shaft diameter is maximum shaft diameter ds max equivalent to ds plus interference plus the tolerance of shaft, this equation. So we get 75.059 millimeter. While for the maximum, actually this is minimum, minimum shaft diameter ds minimum d plus interference, so equivalent to 75.0375 millimeter. Okay, so now turn to your part. So we have exercise 10.1 and question 10.1. So you need to solve this equation and submit through ITEL. So that's all for up to 10.2 tolerance and fit. Thank you.